Hey guys, welcome to Learn Today IGCSE. This video is a tutorial for Physics, Paper 4 Theory, Paper 4-2 from February-March 2024 examinations. For those of you who are taking the May, June and October-November series this year, this paper can be really helpful as in 2023, some of the questions were repeated from the February-March paper. Question 1A. Figure 1.1 is a speed time graph for the first 5 minutes of a bus journey. Remember that the gradient for a speed time graph tells you the acceleration. Describe the motion between time equals to 0.9 minute and time equals to 2.9 minutes. Between this time, we can see that the line is horizontal, whereby the speed here remained constant at one point. So the motion of the graph here is constant speed. Or since the gradient of the graph is the acceleration, the gradient here is 0, which tells us that the acceleration is also 0. Next, from time equals to 2.9 minutes and time equals to 3.5 minutes, which is from this part of the graph. And we can see that the line here is a straight line, meaning that it is constant and the speed is decreasing, so it will be constant deceleration. And next from time 3.5 minutes and time 4.5 minutes, which is at this part of the graph. And we can see that over here the speed is 0, which means that the bus is not moving, so the motion of this bus is stationary. Question B. Another bus travels at a speed of 8.9 meters per second. The brakes apply at a constant force and the bus stops at a distance of 23 meters. This bus has a mass of 18,000 kilograms. So if I were to draw out this question, we know that initially the bus was traveling at 8.9 meters per second, and after traveling a distance of 23 meters, it comes to a stop, which means that its final velocity is 0 meters per second, and this here is its initial velocity. And another information that we have is the mass of this bus is 18,000 kilograms. Part 1 of the question is asking you to calculate the kinetic energy of the bus before the brakes are applied. Whenever you are given a question to calculate, your first step would be to list down all the information that you have. Now, of course, this step is not compulsory, but it will help you identify and understand all the information that you need and which formula would be relatable. You are asked to calculate the kinetic energy. The formula for kinetic energy is 1/2 times the mass of the object times its velocity. So everything is pretty simple over here. We'll just substitute the value. The mass is 18,000 kilograms and the velocity here is 8.9 meters per second, and we need to square this value. Putting this all in your calculator, you should get a value of 712 and 890 joules. But don't forget to change your final answer into two significant figures, which would be 710,000 joules, or if you want to change your answer in kilojoules, it would be 710 kilojoules. The next question wants you to calculate the force applied to stop the bus. Formulas are extremely important in physics, so make sure that you have memorized all the formulas needed. Some formula related to force would be force equals to mass times acceleration, or force equals to work done over distance. If you look into your course specification, you will see that work done is also equal to the change of energy. So the work done here is also equal to the change of energy. So let's see which formula can be applied to calculate the force in this question. Looking at all the quantities that we have, we will not be able to get the acceleration. So we can't use this formula, meaning that we are left with this formula, whereby force equals to work done over distance. The distance is already given in the question, which is 23 meters, and we have learned that the work done is also equal to the change of energy. And the change of energy has been calculated in the first part, whereby kinetic energy is 710,000 joules. Now we can just use our calculator and get our value. 30,869. The unit for force is Newton. And don't forget to leave your answers in two significant figures. So that would be 31,000 and the unit are newtons. Do not forget to insert your unit in your final answer. Next, question 2A. Define impulse. If you're unfamiliar with the definition of a certain term in your syllabus, you can use your course specification to help you with that. Just make sure that you're using the right one, and this is from 2023 to 2025. I will share the link to this PDF copy in the description box below this video. Under your subtopic of momentum, you will see that the definition of impulse has been given to you, as force times time, for which force acts. And you are also given with the equation of impulse. So you can write exactly what is written on your cost specification into your answer space. Question B. Figure 2.1 shows a rocket and its exhaust gases. The exhaust gases are emitted from the rocket with a velocity of 1,400 meters per second and at a rate of 2,800 kilograms per second. So this tells us that at every 1 second it travels a distance of 1,400 meters and 2,800 kilograms of gases is being released. So this here can also be used as our mass. Question part 1. Show that the force exerted on the rocket by the exhaust gases is 3,900 kilonewtons. State the equation you use. Again, we are being tested on force. The formula related to force could be F equals to ma or F equals to work over distance. We are not given any information of distance, neither work, so we can't use this formula. But we know the mass and we can also find the acceleration, so we are going to use this formula. So the mass given here is 2,800 kilograms that is being released per second multiplied by its acceleration. Acceleration is the change of velocity per unit time, and the unit time here is only 1 second since this is per second and this is also per second. So the change of velocity here would be 1,400 meters per second. This will give us a force of 3,920,000. Unit for force would be newtons. Changing this into kilonewtons would be by dividing 1,000, giving us 3,920 kilonewtons. In two significant figures, approximately is indeed 3,900 kilonewtons. So there you go, we have shown that. Next, calculate the maximum mass that this force can lift from the ground. Ignore air resistance. So there are two forces acting on this rocket. The force downward is its weight, and another force that acts upwards to lift it from the ground. We are looking to find the maximum mass. If the weight was larger than the upward force, then the rocket would move downwards. For us to find out the maximum mass that the force can lift from the ground, tells us that the force upward is equal to the force acting downwards. The force acting upwards have been determined from part 1. And weight equals to mass times gravitational acceleration, which is 9.8 meters per second square. So we'll just rearrange this formula, and this will give us a maximum mass of 400,000 kilograms. You can leave your answer like this or change it in standard form, which would be 4.0 times 10 to the power of 5 kilograms. Question 3, part A. A car has a weight of 13,000 newtons. The car is supported by 4 tires. The area of each tire in contact with the road is 0.016 meters square. Part 1. Calculate the pressure on the road due to the weight of the car. As mentioned previously, when you are given with a question to calculate, first list down all the information that you have. Next, identify which formula do you need. There's only one formula related to pressure, which is force over area. Force is also equal to the weight of the object, which means that the force here is 13,000 newtons over the area. You have been given the area is 0.016 meters square, but pay attention here that this is the area of each tire. The car is supported by 4 tires. So let's say this is the weight of the car, which is 13,000 newtons. Since there are 4 tires supporting the weight of the car, the weight or the force here will be equally distributed to each tire of the car. So the area here will not just be the area of one tire of car, which is 0.016. It should be the area of all the 4 tires. That means 0.016 we will have to multiply by 4, giving you a value of 203,125. The unit for pressure is Pascal. Don't forget to change your answer to 2 significant figures. So you can either leave your answer as 200,000 pascals or 200 kilopascals. The unit conversion from Pascal to kilopascal is that you are going to divide by 1000. Next, question part 2. Explain, in terms of particles, why the air pressure in the tire increases when the car travels along the road. The pressure of an object can increase or decrease due to 2 factors. One is volume and second is the temperature. As the car travels along the road, the tires of the car will come in contact with the surface of the road, creating friction. Now, the friction between the road and the tire can increase the temperature of the tire. And when the temperature increases, the kinetic energy of the particle increases, which causes the particles to move faster and collide with the wall of the tire more frequently, which causes the air pressure to increase. So writing all these points will give you a complete 4 marks. Question B. A gas cylinder contains helium gas at a pressure of 2 times 10 to the power of 6 pascals. A volume of 0.026 meter cubes of the compressed gas is released from the cylinder into balloons. Each balloon contains 0.015 meter cube of helium at atmospheric pressure 1.0 times 10 to the power of 5 pascal. The temperature remains constant. Calculate the maximum number of balloons that can be filled. So the pressure of the balloon is at 1 times 10 to the power of 5 pascal. First, we need to find out the volume of gas at an atmospheric pressure which was transferred from the gas cylinder. We can do this by applying Boyle's law, whereby P1V1 is equal to P2V2. So we'll consider this the first one, and for the balloon will be the second. So rearranging this formula, we will get 0.52 meter cube. So now we know that the volume of helium gas is 0.52 meters cube. We are now going to use this volume to fill up the balloons. We know that each balloon can contain 0.015 meter cube. So we are looking to find how many numbers of balloons that we can fill. To do this, we can just take the total volume that we have and divide it with the volume of each balloon, which is 0.015. This will give us 34.6. So the maximum number of balloons that can be filled would be 34. Next, question 4a. Define specific heat capacity. You can get this definition in the course syllabus. It says that specific heat capacity is the energy required per unit mass per unit temperature increase. And this is the formula given. This shall give you a complete 2 marks. Next, question B. A volume of 0.024 meter cubes of oil is heated in a pan for 7 minutes. The temperature of the oil increases from 20 degrees Celsius to 180 degrees Celsius. The density of the oil is 910 kilograms per meter cube. The specific heat capacity of the oil is 2000 joule per kilogram degree Celsius. Part 1. Calculate the mass of oil in the pan. When you are given with question to calculate, as mentioned previously, first list down all the information that you have. You are looking to calculate the mass. To calculate mass, you have got the volume and the density given. So you can use the formula of density, which is mass over the volume. Rearranging this, we will get mass equals to volume times its density. Just substitute the values and you will get 2.184. And the unit here would be kilograms. And change your answer to 2 significant figures, 2.2 kilograms. Next, calculate the energy required to increase the temperature of the coil. Whenever your question is related to specific heat capacity and you are asked to calculate energy, there will only be one formula for this, which is mc theta, mass times specific heat capacity times the change in temperature. The mass has been found from the first part of the question. The specific heat capacity is given for you. And the change of temperature is 180 degrees Celsius minus 20 degrees Celsius, which is 60 degrees Celsius. Just put in all this value in your calculator, and in 2 significant figures, you would get 700,000, and the unit, once you've done the conversion, would be joules. Next question, you are asked to calculate the power required to supply the energy calculated in B part 2. The formula related to power and energy is power equals to energy over time. The energy is 700,000 joule and the time given is 7 minutes. To use the formula of power, your time has to be in seconds. So 7 minutes converted into second, we'll just multiply it by 60 seconds. This will give us a value of 1666.6 and the unit is watts. You will change your answer to 2 significant figures, which is 1700 watts. Please do not forget your units when you are giving your final answers in physics. Next, question 5, part A. Table 5.1 shows applications of regions of electromagnetic spectrum. Complete the second column of the table with the region of the electromagnetic spectrum used for each application. Choose from the regions in the list. Okay, hereby you are given the application in this column and you have to fill it up with the region, and the options are all given over here. They should be pretty easy as long as you have memorized the region and its application accordingly. If you haven't, you can just take a screenshot of these and make sure to memorize them. And also remember the order of the spectrum from the lowest frequency to the highest frequency. Next, part 2. State the approximate speed of radio waves in air. All electromagnetic wave has the same speed as the speed of light in air, which is 3 times 10 to the power of 8 meters per second. Next, question B. Figure 5.1 shows successive crests of a wave after a plane wave has passed through a gap. So the wave has passed through the gap, and this is what we observe. On figure 5.1, draw 3 successive crests before the wave reaches the gap. Okay, when waves go through a gap, it will be diffracted. You must know the factors that affect the magnitude of diffraction. The question shows you the case whereby the diffracted wave looks like this. The waves are curved as a C-shaped, which means that the gap is equal to the wavelength of the wave before it went through the gap. So we are going to draw 3 lines which has the same wavelength as the gap. So this is what it should look like. Part 2, figure 5.2 shows a much wider gap. A plane wave of the same wavelength as in B part 1 is incident on the gap from the left side of the barrier, meaning that we're going to take the same wavelength of the waves from part 1 and put it on the left here. On figure 5.2, draw 3 successive crests of the wave after the wavelength has passed through the gap. As you can see here, the difference is that the gap here is much larger compared to the wavelength. When the gap is bigger than the wavelength, there will be a lesser diffraction. So you're just going to curve a little bit at the end of your waves, like this. And make sure that the wavelength is the same as before. Next, question 6. Figure 6.1 shows a full-scale diagram of an object O and its image I, produced by a converging lens. We have 2 types of lens that you will learn in your syllabus. This is a converging lens, known as a convex lens, and another one is a diverging lens, which is known as concave lens. Question part A. On figure 6.1, draw a single ray to locate the position of the center of the converging lens, and a line to represent the position of the lens and label the line as L. This question here is a little bit different from every other past year questions. Usually they will be giving you a lens and then they will ask you to locate the image. Or they give you an image with the lens and they ask you to locate the object. But right now, as you can see, it's a little bit different. You have the object and image and you are asked to locate the lens. To do this, the rule is the same. When locating an image, you have to always draw a straight line from the tip to the center of the lens. And the second line always goes through the center of the lens, elongate it until it reaches the tip of the image. So we will use our second line here to determine the center of the lens. So we can draw a straight line from the tip of the object to the tip of the image. The point of when the line intercepts with the principal axis is the center of your lens. And we should draw a line to represent the position of this lens. I'll just draw a simple line like this and label it as L. Okay. Next question is asking us to determine the focal length of the lens by drawing another ray on figure 6.1. Focal length is from the center of the lens to the focal point. To determine the focal length, we first must find the focal point. Now that we know the center of our lens, we can draw a straight line until the center, and then from that point onwards, we can elongate and touch the tip of the image. And the line that intercepts the principal axis is our focal point. So we draw a straight line from the tip of the object to the center of the lens. And then from there, we will elongate until we arrive to the tip of the image. This point where it intercepts with the principal axis will be your focal point. And let's label it as F. So the length between the center of the lens to the focal point is my focal length. From here onwards, I can just use a ruler and measure the distance. I get roughly 2.1 as the distance. So the length here is 2.1 and the unit will be centimeters. Next, question C. The object is moved 2 centimeters closer to the lens. State 2 changes to the characteristics of the image. Okay. The object right now is placed at 2.9 centimeter. If it was moved 2 centimeters closer, the object's new position would be over here. So let's see what happens to the image of the object. The first line would be to the center of the lens. and then it will go through the focal point like this. And the second line would be from the tip of the object towards the center of the lens, and we will just extend the line. As you can see, these two lines do not intercept over here. But we can backtrack this line and we will see that the image falls somewhere behind over here. So this means that the image is virtual and it is upright. The image previously was real and inverted. That's how different it would be. That's all for this video. I will be answering the second part from question 7 to 11 on the next video. Thank you. Bye-bye.